Okay, so this is a review video for our vectors quiz. Number 1 says, represent the following graphically. Let me draw it and then find the components. Northeast at 15 miles per hour, that's this way. 45 degrees with a length of 15. So the vector is 15 cosine 45, 15 sine 45. I know the values because that's from our unit circle. You could also type them into your calculator. With the calculator, make sure your mode is in degrees. So I'm going to do 15 cosine 45. Oops. Let me try again. 15 cosine 45, 15 sine 45. And they're equal, so it's 10.6, or we can leave it exact as 15 root 2 over 2, or 10.6, 10.6. Okay, so then for number 2, find the direction and magnitude. So the magnitude, oops, sorry if that's bouncy, is the square root of 9 squared plus negative 2 squared. That's the square root of 85. Then to find the direction, so over 9 down 2 is going to be this way. So I need this whole angle. But when I do tangent of theta equals 2/9, the theta the calculator gives me is going to be the reference angle. So I'm going to do second tangent 2/9, and that is 7.05 degrees. So the direction is 360 minus that. So 352. Oh, you know what? Because, let me see. I don't know if I needed parentheses. Oh, I did. Okay, sorry. This is the only calculator I had at home, and it's different. It's a TI-86. So I needed to type those parentheses. Okay, so the real angle is 12.53 degrees. So 360 minus 12.53 is 347.47 degrees for the direction. Okay, same things. First I have to find component form. So I'm going to do n minus beginning, or terminal minus start, or initial, excuse me. So 8 minus 3 is 5. 5 minus negative 2 is 7. So the magnitude is the square root of 5 squared plus 7 squared. That's the square root of 74. And then 5, 7, if I look for where that is, that's over 5 up 7. It's in the first quadrant. So when I do tangent inverse of 7/5 to get the angle, that's going to be the exact location. I don't have to do the reference angle. So tangent inverse of 7/5 is 54.5 degrees. I'm going to do 2 decimal places, 46 degrees. Okay, so then for B, the vector is 5 minus negative 6, 3 minus 8. So then the magnitude, so let's see, 11 squared plus 5 squared is 146. And then that angle is in the fourth quadrant, so I'm going to have to find that complete direction. So this tangent inverse is going to give me the reference angle of 24.44 degrees. So 360 minus 24.44 is 335.56. So 360 minus that. Okay, number 4, find the components. Well, if it is southeast, that's this way with a length of 2. So this angle, because it's directly in between, is a reference angle of 45, so it has a direction of 315 degrees. So we'll do 2 cosine of 315, 2 sine of 315. And then we can type those in our calculator. We get 1.41, negative 1.41. Or if we want to write that in IJ form, 1.41I minus 1.41J. I'm sorry the video is going to be jumpy. I'm on my coffee table and I didn't realize it was so wiggly. Sorry. Direction 35 degrees north of west. So that's here with a reference angle of 35. So our direction is 180 minus 35. Of 145 degrees. So our vector is 24 cosine of 145, 24 sine of 145. So negative 19.66, 13.77. Okay, that was 21 page. Now on to page 24. "25 degrees northeast direction." So the vector is 24 cosine of 25. Excuse me. And 24 sine of 25. Oops. All right, so that gives us 21.75 and 10.14. The wind is blowing towards the south, 25 knots an hour. So towards the south is this way. So our angle is going to be 270 degrees. So 25 cosine of 270, 25 sine of 270. Cosine down here is 0, and sine of 270 is -1, so that's -25. You can use your calculator if you don't trust your memory from our trig units. All right, find the components with the initial and terminal. I'm going to add in magnitude and direction as practice. Okay. So the vector is 9 minus 2 and 7 minus -4. So the magnitude is the square root of 7 squared plus 11 squared. Square root of 170. And since this is in the first quadrant, theta is going to be our answer. So tangent inverse of y divided by x. And that is 57.52 degrees. All right, so then let's do B. Vector is -5 minus 3 and -4 minus -8. So if we plot that, it's going to be down here in the third quadrant. The magnitude is the square root of 8 squared plus 12 squared. (208). So the square root of 208. And the angle that we find by doing tangent inverse is not going to be our answer. It's only the reference angle, since our vector is not in the first quadrant. So 56.31 degrees is this reference angle here. So I'm going to add 180 to that. So our direction is 236.31 degrees. Okay, find the angle between. So first I need the dot product. So U dot product V is 2 times -3 plus -2 times -3. That's -6 plus +6, which is 0. Oh, I'm sorry, you can't see any of that. Okay, let's try that again. The dot product is 2 times -3, the x components, plus -2 times -3. So that gave me -6 plus +6, which is 0. And I remember that when the dot product is 0, that means the angle, the vectors are perpendicular. But let's just show that with our cosine formula. So cosine theta equals 0 over the magnitudes, which I'm not going to bother to find, because watch this. Cosine inverse of 0 is 90 degrees. So theta is 90 degrees. We're actually going to find everything. Oh, sorry, I hit my stand. Sorry about that. In number 8. So the dot product is 5 times -6 plus 2 times -1. So that is -32. The magnitude of U is the square root of 5 squared plus 2 squared. And the magnitude of V is the square root of 6 squared plus 1 squared. Okay, so cosine theta is -32 divided by the square root of 29, the square root of 37. So I'm going to do cosine inverse of that answer. Now to get answer, you do second negative sign. So theta is 167.66 degrees. It's an obtuse angle. Okay, one more page to go. Number 9. Oh, we got some word problems. Don't panic. A plane flies due west at 250, while the wind blows south at 70. Find the resulting vector and direction. So let's find the component form and then add them together. So let's do the plane at this angle over here. So it's 250 cosine 180, 250 sine 180. Or we know that's to the left 250 and up 0, so -250, 0 for the plane. The wind is going to be over 0 and down 70 because it's blowing south. So the resultant vector, I'll use R, is going to be -250 plus 0 and 0 plus -70. if I sketch that, it's in the third quadrant. So my magnitude, which is going to be the velocity, is the square root of 250 squared plus 70 squared. So that is the square root of 67,400. So 259.62 kilometers per hour. And then the direction, the angle from tangent inverse is the reference angle, so I'm going to have to add that to 180. So let's first find the reference angle. Oops, I need parentheses. That's 15.6, so if I add 180 to that, the direction is 195.64 degrees. Okay. Number 10, a plane flies east for 200 kilometers and then 60 degrees south of east for 80 kilometers. So if I draw like another grid here, so that's a 60 degrees out this way. Find the distance. All right, so let's find the first vector. That's 200 due east, so that's 200 to the right and 0 up or down. But then the second vector, where I have to calculate, so that's going to be 80. Well, okay, 60 is the reference angle, so this whole direction is 300, because it's 360 minus 60. So that's cosine 300, 80 sine 300. So 40 and negative 69.28. So if we add them together, the resulting vector is 200 plus 40 and 0 plus negative 69.28. All right, the distance and direction. So the magnitude is our distance. So the square root of that is 249.8 kilometers. And then to find the direction, my reference angle is 16.1 degrees. So if I think 240 to the right and negative almost 70 down, I'm going to subtract that from 360 since we're in the fourth quadrant, and the direction is 343.9 degrees. Okay, last problem. One force of 100 units acts on an object. Another force of 80 units acts on the object at a 40-degree angle from the first force. Okay, so I'm just going to assume the 100 goes to the right, and then an 80-degree angle from the first force puts the 80 in there. Sorry, it's hard to read. So the first vector is 100 cosine 0, 100 sine 0, which is 100, 0. The second vector then is going to be 80. Oh, sorry, 40 is the angle, not 80. So 80 cosine 40 80 sine 40. Okay, so that gives us 61.28 and 51.42. So if we add our vectors together, we're going to have 161.28, 51.42. Magnitude and direction. All right, so the magnitude is the square root of 161.28 squared plus 51.42 squared. $169.28 units. And then the direction, that's in the first quadrant. So tangent inverse of 51.42 will get us, this exact answer will get us our direction of 17.68 degrees from the first force.